Hello everyone, welcome to my your programming club. Today we will be solving another daily LeetCode problem, and the problem's name is put the double numbers, jumbled numbers. So you will be given a zero indexed integer array mapping, and it will represent the mapping rule of a shuffled decimal system. Okay, so so each entry in this mapping array will be the replacement of the digit at the that index. So if there is a mapping from the ith index to the jth entry in this mappings array, then it means that the digit I should be replaced by the to be mapped with the j digit. Okay, for example, let's open the board. So if a mapping is given to you, let's say it is, and it is to be mentioned that it will always be of size 10, and there will be 10 entries. So from 0 to 9 there will be indexing, since it's a zero based indexing. And if let's say there is entry with respect to 0th index, there is entry of 2, and the number you are given is, or the old number is given to be 0. Okay, then your new number will become 2, because the 0th index, these are the indices. Okay, it is mapped to the number 2, so 0 will be replaced by 2. So this is what the problem statement is meaning here. Okay, so the mapped value of the integer is the new integer obtained by replacing each occurrence of that digit by the digit I in the integer with mapping. Okay, so each digit I will be replaced by its uh, corresponding mapping or the entry at the ith index. Okay, so you're also given another integer array nums. Okay, so there are two integer array given to you. One is the mapping array and another one is the nums array. So you have to sort this given nums array, the second array, in non-decreasing order, or you can say increasing order, based on the mapped values of its element. Okay, so what you will be doing is, let's take one of these examples, and let's read the notes also. Elements with the same mapped values should appear in the relative order as in the input. Okay, and the elements of nums should only be sorted based upon their mapped values, but they should not be replaced. It means that you should be doing the sorting by keeping in mind the new numbers that will be generated by the replaced digits, but uh, the result array that you will be providing should be having the original numbers. Okay, so let's try to understand with one example. Okay, so let's take this one. So let's say this is the input given to you, and let's quickly mark the indices in the mappings array. So these are the indices. Now you, let's convert the very first number to the new number. So this is the old number, and let's convert it. So what is on the ninth index? Since we are looking at two nines, it is 6. So let's replace it. And what is at the first index? It is 9. So 699. And what is at the third index? It is 0. So 00. and then what is at the eighth index? It is 7. Okay, so then for t we have already checked that it was 0. Okay, 0, and for 8 it is 7 again. Okay, so here what will be the resultant? So you can see that both of these are having the same values, but the relative ordering should be preserved. Okay, so that is why you will be, you know, first of all entering this 338, and after that 38 will be entered. Okay, so once you have entered it, then 991 will be entered. Okay, so this will be the resultant array. And if you think about it in a different way also, if you use inbuilt sorting of the language that you are choosing, then also this will work. You need not to take any extra care of it, because although it will be 7 and 7, so these two will be remaining as it is. Okay, so sorting will not change the relative order. So let's have a quick look at the constraints also. So before looking at the constraints, I would like to mention that although the language that we are using will be Java, and since the inbuilt sorting method that we will be using is indeed a stable sort. By stable I mean that if for example here both of the values were having both of the entries were having equal values, in a way stable sort preserves this order, relative ordering of these objects or these entries. Okay, if they are having same values. But if the sort is not stable, it might not preserve the original order or the relative order of these elements. So you should be using stable sort in your preferred language. By default, we since we are have done the implementation in Java, and in C++, we will also provide the code that uses the stable sort. So make sure you are using stable sort. It is nothing fancy here, but it is just that for the objects of equal value, it preserves their relative ordering. Okay, so now moving to the constraints part. So according to the constraints, the length of this mappings array, as I already told you, will be of size 10. Since 0 to 9 the numbers will be represented by the indices, and each entry also will be from 0 to 9. Okay, indices are also 0 to 9 and entries are also 0 to 9, since the digits are that only. And all the values of this mapping are unique. So there are no repetitions here. So there is one to one mapping. Okay. So it cannot be the case like for the 0th index it is 1, and for the third index it is also 1. Okay. Okay, so this case would not happen because all the entries in this array, mappings array, will be unique. So one to one mapping, and nums length, the length of the nums array or the second array will be of order 3 into 10 raised to power 4. Okay, and each entry in this array will be of order 10 raised to power 9. Okay, so let's think of an approach how we can solve this. So as it is very intuitive to do the conversion of the old numbers to the new numbers, and then we can just form the pairs of new and old numbers. So what I'm saying is, so once you have the new numbers generated, so you are having new numbers from each old number. Okay, so let's clear the board a little bit. So These were the old numbers. Okay, so all these three, and you generated the new numbers from it. These are the new numbers, and let's change the color also. So these are the new numbers. Okay, so once you are having them, what you can do is you can form pairs, like 991 is the old number and its new number is 669. Okay, so you can form one pair, and 338, and it will be a little bit convenient for us. I tell you why in a moment, that the new numbers are placed first, because we have to do the sorting according to the new numbers only. So that is why let's place the new numbers first, then the old numbers, and we will form pairs in this manner. Okay, and we will keep doing so. Okay, so we will be having an array of these pairs. Okay, so a 2D array, you can say, sort of 2D array. Then once you sort this 2D array according to its first values in its 1D array internally, so these values, the first values, then you will be getting something like this only. Okay, so not exactly this. Once you sort this in increasing order, you will be getting this according to the first values we are sorting. So 7 and then 38, and the second third entry is 669 and 91 pair. Okay, so you will be getting this once you have sorted it. Okay, sort according to first entry. These entries are I'm talking about. Okay, once you have done this, the task of just updating the nums array is quite simple. You can traverse this sorted array once you are having this, and put the entries, these entries, in their respective places. So you can extract these out and do the replacement in the nums array, and you can simply return this nums array. This that will be all for this problem. And let's have a quick look at the implementations, and after that we will have a quick discussion for the complexities also. So let's see the implementation. So this is the implementation for this problem. I hope it's visible enough for you. So what we are doing here is, as we talked about the procedure, first of all you should be having a new and old number mapping. And as I talked about that, this mapping will be a 2D array. So this is new old number mapping. Okay, so first of all you should be generating the new number from the old number, as when you are traversing the given nums array from left to right direction. Okay, and then you will be forming the pairs of the new number with its old number, respective old number. And as I told you, this array will be having two entries. The first one will be the new number, and the second one will be the old number. So we will be sorting according to this entry. So we are sorting in ascending order according to this entry, and this is to be mentioned that this is a stable sort. In Java it's a stable sort. I will also provide you the code for C++. In that we have used stable sort. So here, as you can see, we are just updating the given nums array with the new sorted order. Okay, so since we have to write only the actual numbers, which are the original numbers, or you can say old numbers, so we will be replacing them with their respective indices. So and then you might have to might be wanting to have a look at the give new number function also, which is generating the new numbers. So since we were told that numbers can be ranging from 0 to 10 raised to power 9, so a number can be 0 also. So if is it it's 0, then it will be a single digit, the old number, and we will simply be returning the corresponding mapping entry in that case. Okay, and if it is not a 0, I mean it's greater than 0 or not a 0, then you will apply this logic. Here what you are doing is you are extracting digits from the end. So if we take this as our example, 1 and 2, so when you will do modulo with respect to 10, you will get 2. So you are in a way getting the last digit. Next time you will get this digit. Okay, so last digit you are getting, and since you are getting the last digit, and if you want to form the new number, it will be formed in the reverse direction. In order to avoid that, we have applied a logic that we will use a multiplier will be starting with value of 1. Okay, and then at each entry we will be multiplying it by 10. Okay, so you can have a dry run of it, but it will give you the correct ordering. Otherwise this thing that we have converted from 991, we have achieved 669. Otherwise it would be 966. Okay, in reverse order if we do not do that. So in order to make sure that everything is set up correctly, we are using this multiplier. And let me quickly check whether we have correctly converted it or not. Yeah, 669 it is. It's fine. Okay, so this multiplier logic ensures that we will be getting the new number generated in the right ordering. So at each time you will be dividing your old number by 10. If we divide 12 by 10, we will get 1 as our quotient. So that's why the last digit that we have just extracted out is eliminated from the number in a way. So each time you will be getting one digit and you are generating the new number, fine, and then you will be returning it. Okay, so now let's talk about the complexities briefly. So time complexity wise, it will be since this loop will be running only order of log base 10, since we are dividing by 10 of old number, or if in simple terms you want to say, it will be number of digits in old number. Okay, and you have seen that the numbers can be as large as 10 raised to power 9. So 1 and after that 9 zeros, you can say order of 10 digits. Okay, so it will not be that large. So you can say that because of use of this sorting that we have done, if the size of the nums array is of let's say n size, then it will be order of n log of n. Okay, and space complexity wise, you must have noticed that here we are indeed using some extra space because this mapping is using the space. Although we are not using the extra space to store our results, we are just modifying the original array. But because of use of this mapping, and it's a 2D mapping, so overall you can say order of n size. Or if you want, you can take it into consideration also, this second dimension 2 size array. Overall you can say it will be order of n. Okay, so these will be the complexities. These are the this is the approach and the implementation also. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. And until next time, keep solving more and more problems, and I will see you in the next video. Thank you for watching.